We are going to start with differentiation. Now, the first thing is differentiation of some elementary functions. Like, first of all, let's say dx. What is dx? It's 1. Okay? And, okay, of course, dx by d of x by dx. Similarly, you have d of x to the power n by dx. That will be n x to the power n minus 1. Okay? This can also be written as d of xn is equals to n x to the power n minus 1 dx. This dx can be carried this to this side. Okay, this is the first thing. Then you have something like d of a to the power x upon dx. Something like this type, 2 to the power x. Then it will be a to the power x ln a, like 2 to the power x ln 2. Okay. Another one is ln x, of course ln mod x. D of ln x is 1 by x. Okay. And of course in ln of minus 2 mod will be ln 2, so or ln 2x, and that will be 1 by 2x. Okay. As like that, you have d by dx. This was ln, so the base was exponential. In this case, you have log a base a x. That will be 1 by x ln a. Okay, the differentiation of this variable. Now, we'll move on with the trigonometric functions. First one is d by dx of sin x, the most basic function, the most basic trigonometric function. That is cos x. For cos x, you have d by dx of cos x is minus of sin x. Similarly, for tan x, you have, or let's first look at sec x, because that's, like a series. Sec x will be sec x tan x. Okay. Now, next important formula, cosec x. This can be written as 1 by sin x, and hence you can calculate this, but for simplicity, I'm just writing this one, cosec x cot x. Similarly, you have d by dx of tan x, which is sin by cos. Okay, so you can just write that sec square x. Then d by dx of the last trigonometric functions, cot x, that is equals to minus cosec square x. Okay, now first of all, let me tell you the basics about differentiation. Differentiation of gh is equals to g differentiation of h. Of course, this all is with respect of x plus h d differentiation of g. This is the multiplication, differentiation of multiplicating terms. Okay. Similarly, g by h is equals to h square h dg minus g dh. Okay. That's the term. So similarly, you can do like d of 1 by sin x. If you want to calculate d of cosec x, you can do d of 1 by sin x, because cosec x is 1 by sin x. Then you will just sin square x, and you will have cos x here and minus here. So minus cos x by 1 sin x will give you minus cot x, and 1 by sin x will give you cosec x. Okay, so it's minus cosec x cot x. But that's how you get the differentiation. Okay, so these are two important rules, that multiplication and division. We'll move on. The next important formula is, well, I must tell you about the f and g, f plus minus g. Okay, d by dx of that, addition also. I have told you about multiplication and division. I'll tell you about this also. This is f dash x plus minus g dash x. Okay, f is a function, f is a function of x, g is also a function of x. Now differentiation of f and g will give you f dash and g dash. We represent this like that. Okay, similarly, differentiation of f of g of x, this is the composite function of fx and gx. This will be, first of all, we'll differentiate with the outermost, that is f dash g of x. Then we'll go inside, that is, this part is complete. Now this part we are going to deal with, this part, that is g dash x, differentiation of this part. Fine. So this is the differentiation thing. if you have one more important thing is, if you have a constant into into fx, then the differentiation, the constant will come out of that dx fx, and this will be k f dash x. Okay, so the constant remains constant after the differentiation, and differentiation of a constant with respect to x will be 0. This is the most important thing. It's always used. Okay, of course, it's always used. Now we'll turn on to the differentiation of inverse trigonometric functions, derivative of inverse trigonometric functions. First function, sine inverse x, d by dx of sine inverse x, that is equals to 1 upon root of 1 minus x square. Okay, like sine inverse x, you have to deal with this. For cos inverse x, you have d of cos inverse x by dx is equals to minus 1 upon root of 1 minus x square. Okay, now this is for x belongs to minus 1 to 1, this too. Okay, x belongs to minus 1 to 1 in them. Okay, now for tan inverse, of course, because this is the domain. Okay, this is the domain, but we cannot include 1 and minus 1, which is in the domain of sine inverse and cos inverse, because you know, at some point this denominator will get negative, will get 0, right? This 1 minus x square will get 0, and 1 upon 0 is not defined, so that's why we don't include 1 and minus 1 in this domain. Similarly, you have d of tan inverse x upon dx. Fine, this is equals to 1 upon 1 plus x square. Similarly, you have d of cot inverse x by dx, that is equals to minus 1 upon 1 plus x square. Okay, mind this, minus 1 upon x. Just like this, if sine inverse is positive, then cos inverse is just the negative of that. If tan inverse is something, then cot inverse is just the negative of that. X here, in these two cases, x belongs to R, because the domain for tan inverse is R, and the denominator can never be, can never be made 0, because 1 plus x square is never equals to 0 at any x in R. Okay, so that's why now d of sec inverse x upon dx, that will be, you got to remember these formulas, 1 upon root of x square minus 1, and d of cosec inverse x upon dx is minus 1, just the minus of this thing, mod x root of x square minus 1. Now, when is this true? This is true in case you have x belongs to, for all x belongs to minus infinity to minus 1 union 1 to infinity. Okay, for all these x, this is defined. Of course, this is also not defined on 0 and x equals to minus 1 and plus 1. Why? Because this will make the denominator 0, and we don't want that. So that's why these are not included in this domain. Now, differentiation using substitution. This is also one of the important topics regarding JEE. Is that it's because you have to you can get something like indefinite integration, and you have to substitute x with something so that you can make the integration simple, right? So following substitutions are normally used to simplify these expressions. I'm going to tell you. First is root of x square plus a square. In always substitute x is equals to a tan theta, where theta is between minus pi by 2 and plus pi by 2. Okay, this is the domain for theta. If you get ever this expression, then just substitute x is equals to a tan theta. Similarly, if you have something like this, root of a square minus x square, then put x is equals to a sine theta. Why? Because this will convert this root into a perfect square. Like x is equal, let's put x is equals to a sine theta. It will give you, let me write it with red pen. It will give you a square is constant, x is a sine theta, so x square will be a square sine square theta. This will be a square, let's take a square common, 1 minus sine square theta. That will give you a square cos square theta. That will give you a cos theta. So you are free of the root function, square root function. That's why we use this type of substitutions, that a sin theta or cos theta, right? Now, moving on. Okay, of course, this is minus pi by 2 to pi by 2. We have included this in that, this minus pi by 2 and pi by 2 in this. Okay, so you have to remember this. Next one is, of course, root of x square minus a square. Well, in this case, you have to put x is equals to a sec theta, right? And theta will be from 0 to pi, just like cos domain. Okay, and theta, of course, is not pi by 2, right? Now, if you have something like root of x plus a, of course, this a sec theta will make this simplify, because x is a sec theta, so x square is a square sec square theta minus a square taken out common, so a square sec square theta minus 1, that is tan square theta, and root of this will give you a tan theta. So you are free of the square root function, and what we have to do is just get free of the square root functions, and these functions will get you there. Now, if you have x plus a upon a minus x, you have to just put x is equals to a cos theta, where theta belongs to 0 to pi.